Hello, I'm Emma. I'm from Rock Power Connections. We're an electrical engineering company, and I currently spend about 95% of my time on electric vehicle charging projects. Today, I'm just going to cover installing EV charging infrastructure at your business. Now, when I talk about EV charging infrastructure, I'm talking about the EV chargers themselves, but everything that's required to get a power supply to them. This can be as simple as coming from your existing distribution board right through to requiring a new connection with a substation. But I'll come back to that. So I'm not going to take long today. It's going to be a very quick whistle-stop tour. My contact details are at the end of this. So if you ever want to get in contact with me, discuss your specific site, your specific requirements, please do. I'd welcome that. Just what I'm going to cover is going to be the different solutions for getting an electricity supply, how to actually calculate the load that you need, just a few extra points to consider, and then how do you take it forward to making that strategy a reality. So I'm going to start with a very quick overview of powering EV chargers. There's pretty much three ways to do it. First off, if you are looking to just install, say, a couple of slow chargers, I'm talking about 3 kilowatt, 7 kilowatt chargers, you might actually have the spare capacity on your existing supply. If you do you have the spare ways in your distribution board? If you do, great. If you don't, it can just be as simple as upgrading your distribution board. If you're looking to install more chargers, or for example, say a couple of rapid chargers, you kind of 50 kilowatts or whatever, and you don't have the existing spare capacity, anything up to say 150 to 200 kVA, you're likely to be granted a new connection from the low voltage network. Once again, this could be quite simple. It just requires new LV cable from the distribution network, and that can terminate, say, into some kind of feeder pillar where you just have a cutout, and then you just have a distribution board after that, which just splits it up into however many ways that you want. If you're actually looking to install a fair few more chargers than that, say anything above, say, 150, 200 kVA, you're looking more than that. You're likely instead to be granted a point of connection at high voltage. This requires you to have a substation on your site, and that supply will then once again come into some kind of LV panel where it's split up and directed to where you need it. Now, in the case of a new connection, be it low voltage or high voltage, you can either have a standalone connection for your EV chargers only, or you may wish to incorporate your other site load onto that and disconnect your existing supply. The one thing that you cannot do is have two supplies into the same building. Looking at this here, as we go through each of these options, they require more space and basically they become increasingly more expensive. And that's why it's really important to work out exactly what load that you need. So here we go, here's a few examples here. This one could just be if you're coming off your existing supply. These could be 11 or 22 kilowatt chargers here. And you might just have some small service underground cables running from your distribution board under there just to each of those chargers. This next photo here, this is a 50 kilowatt charger, and we've installed a new LV connection to this one from the distribution grid. We came from a point of connection in the adjacent footpath and had to cross the road with this one. The black box on the left is the feeder pillar, so that will have the cutout and the meter in it, and then just cables straight through into that charger. This here is a substation that we have installed. It doesn't have the ongoing EV charger infrastructure here, which would be like LV panel and then the charger units themselves. But this just gives you a feel for the size of a substation that would be needed. We usually say they can be about 3 meters by 3 meters, but you have to allow a footprint of about 5 by 5 meters. So, load. This is the pivotal question. I have conversations with clients and they might be looking, for example, for 3 22 kilowatt chargers. Now, these 22 kilowatt chargers might have 2 sockets, and each of the sockets might be able to pull 22 kilowatts each. So suddenly you're looking at 44 kilowatts per charger. You multiply that by 3 and you get, 132 kilowatts. It can all add up very rapidly. But will that realistically be used? If you over-engineer your load requirements, you just run the risk of basically ending up with a more expensive solution than you need for power that you're just never going to use. So these are the questions that I like to ask. First off, what power rating of chargers do you need? And as the boxes below there show, that they usually fall into 3 categories. So you get your slow chargers, which are usually up to 7 kilowatts, your fast chargers, which tend to be between your 7 and your 22, and then your rapid chargers, it says here 43 plus, I usually say about 50 plus. Your slow and your fast, anything up to 22, tends to be an AC charger. Your rapid DC charger, and I'd also say now there's like the new category of your ultra rapid, which tend to be your 150s right through to your 350s, the kind of chargers where you can charge your car in 10 minutes or so. That's the first thing to consider. Next, what will it be charging? Are you talking here about your commercial fleet? Is it employees' own cars? Is it visitors, guests? For example, you might be a hotel and have overnight guests. Or are you a kind of destination premise and people might be charging en route? This is where you start thinking about shops, retails, pubs, that kind of thing. When will the vehicles be charging? Is this during the day? Or is this a commercial fleet or maybe hotel guests that are parked there overnight? How much charge do they need? So there might be a massive difference here between you've got an employee that charges up mainly at home, for example, just comes to the office or whatever during the day, maybe needs a quick top up. Or you might have a commercial fleet that's out there all day and returns, and every night they've only got 25% battery left. What turnaround time is needed? Are they going to be parked up for hours during the day, during the night, or is it something where you need a really quick turnaround and that vehicle's got to be back out again in 30 minutes? And then lastly, how many charging episodes are needed a week? You might find that some vehicles only need 1. So once you've answered all of these questions, it should give you a very good indication of perhaps the number and mix of chargers that you need, not necessarily the load. So thinking about load, these are the extra points to consider. First off, what is the battery charging capability of your vehicle? Your electric vehicle will only charge as fast as the battery will let it. So if you've got a 22 kilowatt charger, AC, and your battery can only charge at 6 kilowatts AC, it's only ever going to pull 6. It's never going to pull that 22. So suddenly, your 22 kilowatt charger, where you've allowed 22 for each socket, might only be pulling 6 per socket. So that's 12 instead of the 44 that you needed. Load management software now. Wow, the load management software is really sophisticated now. Entirely back end. So, once your chargers are installed, you can refigure lots of settings remotely. If you have a set level of load that needs to be shared across all your chargers, you can set that level so that the chargers between them all will never pull more than that amount. Huge amount of flexibility in there. You could have it so that the charges share equally. You could have it so that the vehicles charge in the order in which they pull up and plug in. Or you could even set yourself some priority bays. So if a car pulls up and plugs into one of those bays, regardless of how long the other cars have been there, they will suddenly pull the maximum charge that they can have. Daytime versus nighttime. You might be a premise that actually has quite a large load requirement during the day for your business operation, but actually not overnight. Therefore, if you are charging your vehicles overnight, you might actually be well within your existing supply agreement in terms of the load that you require. Also, if you are considering some, say, slower charges for overnight, but maybe faster charges for any quick top-ups during the day, you don't have to add those two loads together because they're being used at different times. So if it is highly unlikely that those two charges will ever be used at the same time, then don't double count the load. Timed connection. Your distribution network operator might offer you a connection, but limited towards a certain time. For example, they might say you can have this load as long as it's only after 9 p.m. in the evening. And that might suit you perfectly if you've got your vehicles parked up overnight. Diversity, I think we've covered this and a few of the points. It's just about really thinking what is the realistic usage as opposed to just adding up the total load across all of the charges. The DNOs will now let you apply diversity. So yeah, just work out your realistic figure. And finally, future-proofing. So if you're looking at increasing your vehicle fleet or converting your vehicle fleet, say over the next 5-10 years, and you are going to the lengths of getting a new connection to site now, just make sure that you have enough capacity to cover off your future plans, because you don't want to have to be in a position where you put a new connection in now and then in a couple of years' time you actually need an upgraded supply and go through it all over again. So once you've thought about chargers and the load you require, where do you go to next? First off, if you don't need much of a load and you have that spare capacity, do you have existing spare ways on your distribution board? If so, great. If not, new distribution board. This works all after the meter, so can be undertaken by an electrician, for example, somebody with NIC, EIC accreditation. In the other case where you do need a new upgrade, the first thing to do is apply to your distribution network operator. In the Midlands, it's WPD, other areas, Northern Power Grid, UKPN, Electricity Northwest, SPEN, SSE. They will assess, first off, whether the load is available locally, and second off, they will do a harmonic analysis as well to understand whether the local network can accommodate the harmonics from the chargers, and they will tell you whereabouts on their network you can take your new connection from. They can even give you a quotation to tell you how much it's going to cost to get that new supply. They can do all that work for you. There are other companies called independent connection providers, of which Power Connections is one of them. And we can also do that work for you. It's a competitive market. So you can get a quotation from them, but then also, do feel free to approach us and see if we can offer you a more competitive price for that. So there we go. Like I said, it was going to be a whistle-stop tour. You might have very specific requirements for your site. You might not be sure of what charges or the best way to achieve it. Here I am. Here's my number. Here's my email address. Please do feel to just get in contact if you want to have any further discussions about how to sort your electric vehicle charging needs. Thank you.